Okay, Calc, law of cosines is this section, and this is again used for oblique or non-right triangles. Um, for right triangles, what you would use is SOHCAHTOA. You would do that sine, cosine, tangent, that type of thing. But for oblique triangles, you have to use the law of sines and the law of cosines. Law of sines, we used that when we had two sides and two angles. One of those we're solving for. Okay, so one of those four things is what we're solving for. The law of cosines you use when you have three sides and one angle, one of which you're solving for. So you're either solving for one of the sides or solving for the angle that you are looking for. Again, we have A, B, and C, and the sides are the ones that are opposite those angles. Okay, I'm going to circle just this top equation here because really the other two equations are the same as what this top one is, but they're just, the variables are switched around, and it doesn't really matter what you name A, B, and C, except for the fact that lowercase a and capital A, those two have to match with each other. And what I mean by that is if this is the angle that we have or the angle that we're looking for, then this has to be the side that's opposite that. But otherwise, B and C can be switched around, okay? Kind of like if you just look at this first part, a squared equals b squared plus c squared. That's kind of like the Pythagorean theorem, right? C squared equals a squared plus b squared. They've just renamed the things instead of calling it c squared, b squared, and a squared, you know, that type of thing. They've just renamed the variables. But in addition to the Pythagorean theorem, we have to do minus 2bc cosine of a, okay, because the Pythagorean theorem only works for right triangles. So this kind of accommodates the fact that we're dealing with a triangle that's not a right triangle, okay? So three sides, one angle. Here are my three sides, A, B, and C, and then my one angle is A, okay? So down here, example one, find the three angles of the triangle in the following figure. Yeah, let's do this. So we have lowercase a, we have lowercase b, lowercase c. Let's say we're trying to find capital A first, just like the formula says, okay? So what I want to do is if I'm trying to solve for capital A, I want to put lowercase a in this spot right here. So lowercase a, this has to be 8. So 8 squared equals, and then it doesn't really matter which one I call B and which one I call C. They are named B and C in this diagram, so we'll just leave them as B and C. But what I mean by that is that 14 and 19, you could technically flip those two around. And you could put the 14 first and the 19 second, and it doesn't really matter. Okay, minus 2 times B times C times cosine of capital A. Okay, this guy is what we're solving for. Okay, so I'm going to simplify as much as I can. I know that 8 squared is 64. Okay, 19 squared, that I don't know. 19 squared, I'm going to go ahead and put 19 squared and 14 squared together. So 19 squared plus 14 squared. This is going to give me 557. Okay, now the mistake that I see people make all the time is they want to do 19 squared plus 14 squared minus 2 times 19 times 14 and figure out this whole chunk at one shot. Okay, you don't want to do that because this 2, 19, and 14 are attached to the cosine of A. So those guys have to stay strapped on the front of that cosine of A until you can get rid of them. Okay, so I am going to multiply the 2, 19, and 14 together though. 2 times 19 times 14 is 532 cosine of A. Okay, and then after that, I cannot put those two together. I can't put the 577 minus 32 together. Okay, what I have to do is just move everything to the other side. Okay, so I'm going to subtract 557 first, which is going to give me a negative number, and that's okay. So I have 64 minus 557. I think I said 577 earlier. Negative 493 equals negative 532 cosine of A. Okay, and then I'm going to divide by negative 532. Divide by negative 532. Cosine of A will give me that number, negative 493, divided by negative 532. 0.927, something like that. Okay, now Remember from the last section that when we're solving for an angle, we have to get rid of that cosine, or the sine in that case, from the last problem, by doing the inverse function. Okay, so cosine inverse, these two will cancel out, so I just have a by itself. And then I'm going to do, oh shoot, I want to go back. I want to go back. Poop, 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 poop. Let me do that again. Negative 493 divided by negative 532. Okay, and I want to do inverse cosine of that guy. And I get 22.1 degrees is what angle A is. Okay, if I go back and do that. All right, so now I've solved for angle A, 22.1 degrees. Okay, now the beautiful thing about this is I could go back through and do this whole process again and solve for C or B, doesn't really matter. But now that I have one angle, I can use the law of sines now instead. Okay, so that's what I'm going to do in this case. Okay, so since I have a pair here, I have 8 and 22.1. Let's say we're going to solve for C next. Why not? We'll go out of order. Okay, those are the two groupings that I want. So the two sides that I have are 8 and 14. Okay, sine of something and sine of something. Okay, the 8 is across from 22.1, and 14 is across from C. I'm going to put them like that, and then I'm going to cross multiply. Okay, so I'm going to cross multiply and divide. So 14 times sine of 22.1. 14 sine 22.1. Okay, that's my cross multiply. Okay, then I'm going to divide by 8. Divide by 8. Okay, and that is 0.658, which seems like a really small number, except that's what sine of C is. Okay, not just C, that's what sine of C is. So how do I get the C by itself? I take inverse sine of that guy, and I get 41.2 degrees is what that guy is. So we're getting faster. This angle C is 41.2 degrees. Now I could do the whole process again if I wanted to solve for B, but why do I do that if I can just add those two together and subtract from 180? So 41.2 plus 22.1, and then I'm going to take 180 and subtract that. And B is a big angle. B is 116.7 degrees. All right, so it gets a little bit better. You should never have to do the law of cosines more than once in a triangle. Okay, you've got to be kind of careful because when we did the law of sines the second time, 22.1 was the angle that we used, and that was a rounded angle, so technically 41.2 is even further rounded than that, so you have to kind of be careful about when you do that, but you know, we can always just use the law of sines the second time after we find the angle. Okay. Example 2, I'm going to skip that one because we're going to go do a problem on the back side that's kind of similar to this one. I might have you do this one as an example after that. We'll see if I put that as a question. Heron's formula is formula for finding area. And we're going to skip this guy just because I don't have him memorized. He's a really big, long formula for finding area. So example 3 we will skip. But let's go to example 4 here. So the pitcher's mound on a women's softball field is 43 feet from home plate. Okay, so this is 43 feet right here. It will make a 45-degree angle to first base over here. Okay, and the distance to first base is 60 feet. Now, it's important to know that the pitcher's mound is not completely horizontal to first base, or in other words, it's not an equal distance from second base to home plate. The pitcher's mound is not exactly in the middle. It says the pitcher's mound is not halfway between home plate and second base. It's closer to second base than it is to home plate. Okay, so this angle right here is not a 90-degree angle. Okay, they want us to find the distance that the pitcher's mound is to first base. Okay, so we're just trying to find this side. Okay, and we know that we need to use the law of cosines because we have 3 sides and 1 angle. Or one angle that we have is 45 degrees. Now, one of the sides we are solving for, but we do have 3 sides, 1 angle. Okay, so the thing that I want to make sure of when I do the law of cosines Law of cosines, if I write it out here, is a squared equals b squared plus c squared. That's the Pythagorean theorem part. Then I have to subtract out 2bc cosine of a, okay? All right, so they have these labeled as h and all this other good junk. There's no a, b's, and c's, but the thing that we need to remember is that this side has to be opposite this angle. Okay, so the only angle that I'm given is 45 degrees, so I'm going to leave that as cosine of 45, which means that this side A has to be my h that I'm solving for, because that's opposite the 45 degrees. From there, it doesn't matter which one I call B and which one I call C. Okay, so 43 is one of the sides. Let's call him B. 43 squared, 60 squared, minus 2 times 43 times 60. And then I have cosine of 45. Okay, now this one is probably the problem that they should have started with, because this one is way easier than finding the inverse cosine. I should just be able to do a bunch of this stuff all together and get an answer. Okay, so if you do not feel comfortable typing that all into your calculator all at one shot, you can do it in pieces. I'm going to go ahead and try to type it in all at one shot. So I should be able to do 43 squared plus 60 squared minus 2 times 43 times 60 times cosine of 45. Okay, the order of operations should go in that order. Like, it'll do this multiplication stuff first. That's what I want it to do. So I have h squared equals 1800.33, let's say. Okay, wow, really big number, but I have to take the square root of that. Okay, that's the last thing that I have to do. So I'm going to do the square root of that answer. I love that answer button because then I don't have to retype anything. And that is 42.4 feet. So this guy is only about 42 feet from first base. Okay? All right, last question. Now this has to do with bearings again, so kind of the same as what the last problem that we had on the law of sines, 13.1. A ship travels 60 miles due east, so we're going to say that we're starting here at A. Start, and we travel 60 miles from here to here, from there to B, 60 miles. And then we start going in some sort of a north direction for 80 miles, and we stop at C, and we kind of turn around and look, and we notice that we are now 139 miles from where we were before, okay? Or where we started from, I guess. So this guy is going to be 80, 139, 60. Describe the bearing from point B to point C. So let's talk about and let's find this angle right here. Okay, let's talk about that angle. So what this guy is, we have three sides and one angle, so we're going to end up solving for that angle B. Okay, so I'm going to use this formula, same formula as what I had up here. Okay, I need to remember that cosine of the angle that I'm looking for, cosine of B, this guy has to be side B over here, so I'm going to put 139 squared here, and then it doesn't really matter which one goes first. I could do 60 first, or I could do 80 first, doesn't matter. Minus 2, 60, 80, and then cosine of B. Okay, so I'm going to do some of these pieces here. 139 squared is 19,321. All right, then I'm going to go ahead and add the 60 squared and the 80 squared together. So 60 squared, 80 squared is, holy cow, 10,000 minus 2 times 60 times 80. Here, 9600 cosine of B. Now make sure you do not try to put 10,000 and minus 9,600 together. Okay, that's attached to the cosine of B, so we've got to rearrange this thing. I'm going to subtract the 10,000 first. Subtract 10,000. He's gone. Yeah. Okay, so 19, well, I guess if I subtract 10,000, that'll be 9,321 equals negative 9,600 cosine of B. Okay, all right, now I'm going to divide by the negative 9,600. Okay, 9,321 divided by negative 9600. And cosine of b will be negative 0.97. All right. Ooh, that was a lot of work. Okay, now we can do cosine of that answer, inverse cosine of the answer. We gotta do inverse cosine. Inverse cosine. So our b will be 166.2 degrees. Okay. Shh. All right, 166.2 degrees. Okay, now they want us to describe it as a bearing from point B to point C. Okay, so what I'm going to do is, rather than writing that as 166.2, last thing, I'm going to find out what this angle is. Okay, all the way straight across here is 180. So that angle, if I subtract this guy from 180, that will be 13.8 degrees. 13.8 degrees. Okay, so we want to go 13.8 degrees. And this direction this way is east. So we start by going east, but this is actually 13.8 degrees north of the east direction. Okay, so you remember from last section, we said 13.8 degrees north of the east direction. Okay, so that's kind of how you read that. Okay, we could have also, talked about this as being east of north. So it would, instead of being 13.8 degrees east, north of east, it would be like, 76 degrees east of north instead of 13.8 degrees north of east. Okay, so we could have written it that way as well. But I'm just going to leave my answer as east, as north of the east direction. And that's where C lives. Okay.